On the 14th of September, 2023, a trail camera mounted to a lodgepole pine on the eastern bank of Alum Creek recorded a herd of 23 elk moving through the Hayden Valley in the blue half-light before dawn. The largest cow was leading. The calves pressed close to their mothers. The breath of each animal rose in small white columns above the frost-edged sedgegrass. 30 seconds after the elk passed through, a coyote trotted into the frame from the north, nose down, following the same corridor. By 7 in the morning, the trail was empty again, and the morning looked like every other morning in the park. That camera had recorded similar images 412 times over the previous 18 months. Elk crossings at dawn, mule deer picking through the sedge at dusk, a grizzly bear pausing mid-frame, then swinging its broad head toward the timberline and moving on. The Alum Creek corridor was one of the most consistently trafficked wildlife paths in the Hayden Valley, used by multiple species at predictable intervals, reliable enough that biologists from the Yellowstone Wolf Project had incorporated it into the baseline reference data for 2 separate predator-prey interaction studies. The camera recorded nothing on October 3rd, nothing on October 4th, nothing on the 5th, 6th, or 7th. By the 14th of October, 11 consecutive nights had passed without a single animal crossing a corridor that had never before gone quiet for more than 2 days in a row. No storm had moved through the valley. No road construction. No helicopter surveys. No documented human disturbance within 3 miles of the camera station. The camera was functioning. The path was dry and clear. The animals were simply gone. A field technician logging the data at the end of October added a note to the observation file. Aberration, possibly related to ungulate dispersion following early snowfall on the Absaroka Range. Will monitor. It would have meant nothing, except that it was not the only one. Yellowstone National Park runs 45 miles from north to south and 63 miles from east to west, covering an interior plateau of high-altitude grassland, geothermal basin, and conifer forest that sits roughly 8,000 feet above sea level. The park's trail camera network, maintained by the Yellowstone Wolf Project and partner research teams, places approximately 70 active cameras across this terrain. Cameras at bison crossings on the Firehole River Flats, cameras above beaver ponds on Slough Creek in the northern range, cameras on ridgeline passes above the Yellowstone River Canyon where the Douglas fir thins out and the elk trails converge into choke points. These cameras produce thousands of images each week. Sorting them is not a fast process. Field technicians compare current capture rates against historical baselines, flagging anomalies for review weeks after the images are taken. By early December of 2023, 3 researchers working independently in their respective monitoring grids had flagged the same anomaly. A camera at Mary Bay on the north shore of Yellowstone Lake. 0 wildlife traffic for 9 consecutive days in late October. A camera above Pelican Creek, east of the thermal basin. 14 days of empty frames during a period when elk should have been moving through in significant numbers. A camera along a bison migration corridor in the Hayden Valley Flatlands. Placed there in 2021 as part of a predator-prey study, 16 days of empty frames, then a brief return of 2 mule deer on a single night, then silence again. 1 flagged corridor is a curiosity. 3 flagged corridors across a connected landscape during a season when wildlife traffic historically peaks is a pattern. The researchers pulled GPS collar data for the wolves currently active in the park. What the data showed was not a coordinated pack behavior. It was not a predation event that had scattered prey across the region. The GPS records pointed to 2 individual animals. A large male, carrying a collar designation from the Yellowstone Wolf Project, estimated at 110 pounds, based on his most recent capture and measurement in the summer of 2022. And a female, roughly 20 pounds lighter, but documented by field technicians as unusually assertive in territory interactions, particularly at corridor boundaries where her packs range abutted adjacent territories. Both animals belong to the Wapiti Lake Pack, the largest wolf pack in Yellowstone. At its peak during the 2022 winter census, the The Wapiti Lake Pack counted 22 members, ranging across the Central Plateau and portions of the Southern Range, in a territory that spans hundreds of square miles of high-altitude thermal basin and subalpine meadow. The GP's log showed these two wolves moving through the flag corridors. But not simply moving through in a way that appeared to be generating a silence in the landscape around them that was spreading beyond the paths they physically traveled. The corridors went quiet, not only when the wolves were present. They stayed quiet after the wolves moved on. Days after, sometimes more than a week after. No one had an immediate explanation for the scale of it. Not enough to confirm. Not enough to dismiss, but enough to keep looking. The gray wolf, Canis lupus, was eliminated from Yellowstone in 1926. Federal predator control agents shot the last confirmed pack in the Lamar Valley, a broad grassland corridor between the Absaroka foothills and the Northern Range. For nearly 70 years, the park existed without its apex predator, and researchers who studied the ecosystem during those decades documented what that absence looked like in biological terms. Overgrazed stream banks, destabilized riparian corridors, cottonwood and willow stands depleted to the point where songbird habitat across the entire Lamar drainage collapsed. The reintroduction in January of 1995 brought 14 wolves from Alberta, Canada, released into 3 separate acclimation pens across the Northern Range. By 1996, the population had reached 31 animals in 3 packs. By 2005, 118 wolves in 11 packs were ranging across the park and the adjacent national forest lands. The elk, bison, and deer populations began to reorganize their behavior in ways that surprised even the researchers who had predicted the change. As of the 2022 winter count, Yellowstone holds approximately 108 wolves distributed across 8 packs. The Wapiti Lake Pack occupies the Central Plateau and portions of the southern interior. They are the best-studied pack in the park at their scale. Their behavior, at the population level, has tracked consistently with what the models built after 25 years of reintroduction data predicted. These 2 specific wolves are not tracking consistently with those models. Both animals are healthy. Both are breeding-age adults. Captured data from their most recent net-gun helicopter operations shows no injury, no nutritional deficiency, no disease markers. They hunt, they travel, they raise young. They do everything wolves do inside a functioning apex predator system. But the geographic radius of their behavioral influence on prey species, the ring of suppressed movement and altered trail use radiating outward from their core activity areas, is larger than the models say it should be for 2 animals. And in the 2 years since the first anomalies appeared, that radius has not contracted. If you have ever seen something in a wild landscape that did not fit the pattern you expected, subscribe. This channel covers the cases wildlife science has not yet closed. To understand the mechanism behind what the cameras appear to be recording, you need the framework that a pair of ecologists put forward in a 2001 paper published in the Canadian Journal of Zoology. Researchers John Laundre, Lucina Hernandez, and Kelly Altendorf were working in Yellowstone in the years immediately following the wolf reintroduction, and what they observed in the elk herds led them to develop a concept they called the landscape of fear. The argument was precise. Prey animals do not respond only to the physical presence of a predator. They respond to the perceived risk of predator presence, and they calculate that risk continuously using a combination of sensory data, learned spatial memory, and the behavior of other prey animals around them. A cow elk does not avoid a willow-choked creek bottom because a wolf is standing in it. She avoids it because a wolf has been there, because the geometry of the canyon walls above the creek makes escape uphill difficult, and because she has learned across multiple encounters that this class of terrain combined with this class of olfactory signal is a situation from which some elk do not return. Wolf scent marks persist in cold, dry environments for days. Urine and gland secretions deposited on trail margins, on the bases of prominent tree trunks, on rocks above creek crossings, carry chemical signals that ungulates can detect at concentrations far below what any field instrument can measure. Published research on elk predator response physiology has documented measurable cardiovascular stress responses in elk crossing terrain that carried wolf scent, even in the complete absence of any visual or auditory wolf cue. And even when GPS telemetry data confirmed the scenting wolves were more than 10 miles away. 10 miles. That is roughly the distance between the Alum Creek corridor in the Hayden Valley, where the first camera anomaly appeared, and the Pelican Creek grid to the east, where the second researcher flagged empty frames 2 weeks later. The Wapiti Lake Park's territory covers an area exceeding 4,500 square kilometers. Within that territory, 2 individual animals moving along established travel routes can deposit scent marks at intervals frequent enough that the chemical record of their passage saturates a significant fraction of the landscape. Prey species do not require the wolves themselves to be present. They require only the evidence that the wolves have been present. And in terrain cross hatched by 2 animals moving regularly through multiple corridors, that evidence can be near ubiquitous. What the camera data appears to be capturing is not a predation event. It is the behavioral consequence of a reputational presence, a landscape so consistently marked by 2 particular animals that other species have recalibrated their risk assessment across sections of terrain they now avoid on their own initiative. The mechanism is real. The scale of what these 2 animals appear to be doing is where the question opens. Individual behavioral variation among gray wolves is documented and ecologically significant. Research teams from the Yellowstone Wolf Project and affiliated institutions have tracked the hunting efficiency, territory behavior, and social dynamics of individual wolves across multiple decades. And the data consistently shows that wolves within the same pack, with the same access to prey and the same pack resources, perform differently enough to matter at the ecosystem level. Certain individual wolves have been noted in field records for unusually high rates of scent marking, where an average wolf moving through its territory marks prominent landscape features at intervals consistent with general territorial advertisement. A small subset of animals marks at rates 3 or 4 times higher, and with a spatial logic that targets decision points, junctions where multiple trails converge, the narrow margins of creek crossings where approaching animals must slow and commit to a route, ridgeline passes where sight lines open, and the wind is reliable. Marking at decision points does not simply announce the wolf's presence. It inserts the wolf's chemical signature into the moment when prey animals are most cognitively engaged with their environment, most likely to encode a new spatial association between this location and risk. The male in the Wapiti Lake pair exhibits a marking rate that field technicians who have followed his GPS trail on foot have noted as substantially above the pack average. The female's behavior differs in emphasis, but compounds the effect. Her marking preference targets the decision point locations, the creek crossings, the trail junctions, the ridgeline notches above the Hayden Valley where the elk trails funnel before dropping toward the thermal flats. Together, these 2 animals appear to be creating what amounts to a saturated chemical map across a large section of connected terrain. There is documented precedent for this kind of behavioral influence by individual wolves. The Druid Peak Pack, which dominated the Lamar Valley from roughly 1997 through 2010, suppressed elk use of the valley floor to a degree that researchers measured through aerial surveys and direct observation. What was notable about the Druid Peak suppression was that it persisted even when GPS data placed the pack in the adjacent Specimen Ridge drainage, miles from the valley floor. The elk were not avoiding wolves they could see or hear. They were avoiding a location that their behavior had encoded as dangerous. Even after the Druid Peak Pack declined in size through the late 2000s, reduced by mange and pack fragmentation, the elk did not immediately return to full use of the valley floor. The behavioral suppression outlasted the wolves that created it. The Wapiti Lake pair appears to be creating a comparable effect with 2 animals rather than a pack, faster than the Druid Peak pattern, across a larger footprint, and with a mechanism that current models, built on pack-level data, have not yet successfully predicted. Honesty requires saying plainly what the skeptics get right. Yellowstone is one of the most intensively monitored terrestrial ecosystems in North America. The Yellowstone Wolf Project has issued annual reports on wolf population dynamics, pack movements, and predator-prey interactions every year since the reintroduction. University research teams from Montana State, Utah State, and the University of Wyoming, among others, maintain active field presence. The park's research portfolio on carnivore behavior runs to thousands of peer-reviewed pages. If two wolves were producing a behavioral anomaly of the scale and consistency described by the camera flagging data, the objection goes, there should be a published study by now. The absence of a formal paper is itself a data point. That objection is legitimate. It deserves a direct answer. The answer comes in three parts, and not one of them requires the anomaly to be absent. First, coverage. 70 cameras distributed across 2,200 square miles of terrain is not a monitoring system. It is a sample. The flagged corridors represent a fraction of the total trail network. The vast majority of the park's interior terrain sits between cameras, producing no images, no data, no record. What the cameras show is what happened in front of the cameras. What the cameras cannot show is what is happening in the miles of canyon, thermal basin, and subalpine forest where no camera is mounted. The empty frames on the active cameras are what has been noticed. The scale of the effect across unmonitored terrain is, by definition, unknown. Second, classification. When a field technician logs a period of reduced camera activity, the default interpretive framework is population level and seasonal. Prey dispersion in response to early snowfall. Shift in ungulate elevation gradient. Normal variation in corridor use. The classification system used to process Yellowstone camera data was designed to detect trends across entire species populations, not to identify behavioral anomalies tied to two specific individual predators. An observation that might look like a landscape of fear effect generated by a pair of unusually high-impact individuals requires a research framework designed specifically to look for that. That framework was not in place when the first corridors went quiet. The data flagged by 3 researchers in December of 2023 is the beginning of a documentation process, not the end of one. Third, the nature of the signal itself. What anyone attempting to study this phenomenon is measuring is not the presence of animals in corridors. It is the sustained absence of animals in corridors where they should be present. Absence does not generate physical evidence. A corridor that no elk crosses for 16 days leaves no tracks in the dry clay, no hair on the wire, no scat, no carcass. The absence is the signal, and an absence-based signal requires a baseline long enough and complete enough that the anomaly becomes statistically legible. Assembling that baseline takes time. The absence of a published explanation is not evidence of the absence of something worth explaining. Return for a moment to the Hayden Valley in the first week of November, 2023. The lodgepole pine at Alum Creek is the same tree. The frost-edged sedge has gone brown in the cold. A thin skim of ice has formed on the shallower sections of the creek where the current slows near the bank. The Absaroka Range to the east carries new snow on the upper ridgelines, the white running down through the spruce and fir toward the tree line and stopping. This is the window of year, October through December, when elk congregate along valley bottom watercourses at lower elevations across the Hayden drainage. Trail cameras at Alum Creek have historically recorded their highest annual capture rates during these weeks. The elk come down from the high country. They follow the creek corridors through the thermal flats toward Winter Range. The cameras fill up with images. The camera at Alum Creek recorded a single mule deer crossing on the 3rd of November, then nothing through the remainder of the month. The GPE's collar data for the 2 Wapiti Lake wolves places both animals in the Pelican Valley drainage during most of this period, 11 to 14 miles east of Alum Creek. Not in the Hayden Valley. Not near the thermal flats. By every established measure of wolf behavior and prey response dynamics, a corridor the wolves were not actively using, that carried no fresh scent deposits from the preceding several days, should have seen a return of at least partial normal activity. The elk were somewhere in the landscape. The corridor was open. The wolves were documented elsewhere. The elk did not return. The question is not whether wolves reshape the behavior of other species in Yellowstone. That has been demonstrated across 3 decades of post-reintroduction research, from the recovery of streamside willow stands along Soda Butte Creek to the measurable change in elk grazing patterns across the northern range. The broader answer has been known for years. The question being asked now is narrower and harder. Whether 2 individual animals operating at a scale and behavioral intensity that the existing models did not predict can make portions of a landscape functionally inaccessible to other species in a way that persists beyond their physical presence, beyond the detection range of their scent, possibly beyond the parameters of the frameworks designed to study it. The camera at the Alum Creek crossing is still mounted to the same lodgepole pine. The corridor is still there between the bank and the tree line. The creek still crosses the frozen grass in the same shallow bend it always has. And somewhere in the Wapiti Lake territory, 2 wolves are moving through timber and thermal basin and high-altitude snowfield, leaving behind them a silence that, as of this moment, no one has